Hello guys, welcome to Solving Solutions on Bound channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to look at the square of a matrix. Now, this particular concept was born out of geometric computation or maybe adjustment computation, right? Good. So where we have this least square principle that says the sum of the square of the residual is a minimum, because most of the times the residuals are denoted with v, right? So now that are v squared, so that was what brought about this particular square of a matrix concept we have on today's tutorial. So first off, let us look at the steps to compute the square of a matrix. Now if you want to find the square of a matrix, it is actually multiplying the matrix by itself, right? Good. And then you know that there are conditions for two matrices to be multiplied, right? Good. So the first step is that ensure that A is a square matrix. That means it has the same number of rows and the same number of columns, just like we have 2 by 2, 3 by 3, 4 by 4 and the rest of that. So for a square matrix A, A squared is computed as this. So it will now be A multiplied by A. Now another thing is that for two matrices to be multiplied, the column in the first matrix must be equal to the row in the second matrix, right? Good. So we have something like that here. Good. Now we say the multiplication requires the numbers of columns in the first matrix to equal the number of columns in the second matrix. Now when you have a square matrix, it simply means that the column in the first is actually equal to what? The row in the second, right? Good. So when you have a 2 by 2 and then you multiply it, in our case we have 1, 2, 3, 4 as the elements. So it will now be this one multiplied by 1. That's 1 times 1 plus 2 times 3. That's 6, right? Good. So 1 plus 6 will give you what? 7. So that's how you do your multiplication. You go from this row to this column, from this row to the next column. You come to the second row, the first column, and then the second row to the second column, right? Good. So you now arrive at this. However, what our interest is on today's tutorial is not even the square matrix, because multiplying the square matrix is somewhat easier, right? Good. Now let us come to, but if the matrix is not a square matrix, then squaring the matrix is not defined. That means if the number of rows and number of columns are not the same for the both matrices, then it is not defined. Because for a matrix to be multiplied, it requires that the number of rows in the first matrix must equal to the number of rows in the second matrix. However, there are alternative operations for non-square matrix. So if you need to perform operations on a non-square matrix, consider the matrix product with its transpose. Now this is where our interest lies. This is the crux of today's tutorial. Now matrix product with its transpose. So we are going to use our calculator. Let's take it to the matrix mode. So you click on mode and then you select 6, right? Good. The first thing is that we need a matrix A, right? Good. That's the first matrix. And then the next thing is that from our question, we have our A to be a 3 by 2 matrix. That's 3 rows and then 2 columns, right? Good. So we have to select 2, which represents 3 by 2. So we now impute our elements to be 1, 2, 3, 4, 5, and then 6. Right, good. So matrix A has been imputed on our calculator as 1, 2, 3, 4, 5, 6. Right, good. So we would go back. Then we come back using the shortcut. We already know matrix A, right? Good. The next thing is, let's come to transpose. So we click on transpose and then we still come back to matrix, and then this time around we select 3 because we want to transpose matrix A, right? Good. Then we click on equal to. So now it has been transposed. Are we together? So the first thing is that the alternative operations, one of the alternative operations to carry out for a non-square matrix, if you want to find the square of that matrix, is to multiply the matrix by its transpose. So we have imputed our matrix, a 3 by 2 matrix, and then we have gotten the transpose, right? Good. Now this transpose will now be multiplied by the matrix. Remember that in matrix multiplication, A transpose A is not the same thing as A transpose. Are we together? It's actually very important to note that if you have A transpose A, it's not equal to what? A transpose. That's why the order is what? Very important. Now, when you look at this, you are going to see that these two matrices are multipliable, because this is what our A transpose, and then our A transpose is what? A 2, that's 2 row, 3 column, right? Good. And then our A matrix is what? 3 row and what? 2 column, right? Good. So it now gives the column in the first matrix to be equal to what? The row in the second matrix, right? Good. So that now makes them what? Multipliable. Therefore, the product matrix will be what? A 2 by 2 matrix. That's what you have seen here. So we are going to carry out the multiplication using the calculator. So this is the A transpose, right? Good. So to carry out the multiplication, let us confirm what? The elements of matrix A. So we come to shift 4, that's what? The matrix mode, and then we click on 3, which is matrix A. So matrix A is giving us what? The transpose of what? Our A matrix. So we are going to define another matrix that will now be the A matrix itself. So we are going to call that one B, right? Good. So we don't get things mixed up. We have shown you how to get the transpose of what? A, right? Good. So the transpose of A has been stored as what? Matrix A, which is this one, right? Good. So we come back to matrix again. This time around we have data, which is 2, and then we want to impute it as what? Matrix B, which is 2, right? Good. So our matrix B, which is our matrix A in this case, it's what? A 3 by 2 matrix, right? Good. So we select 2 there, then we impute the elements. So we have 1, 2, 3, 4, 5, and 6, right? Good. So this is our matrix A imputed. Finally, what we are now going to do is that we now do what? A multiplied by B, which is what? Matrix A multiplied by matrix B, where matrix A is actually what? A transpose, and then matrix B is actually what? A in our context, right? So we click on AC, we come back to the matrix mode, then we have what? Matrix 3 multiplied by, we still come back to shift, and then we click on 4, that's B, right? Good. So we now expect what? A 2 by 2 matrix, right? Good. Good. We now have our 2 by 2 matrix. We have 35, 44, 44, 56, right? Good. So this is the alternative, one of the alternative methods that you can use to get the square of a non-square matrix, right? Good. Now, it's commonly used in machine learning and linear algebra. However, what made us produce this video was because of its use in adjustment computation, that least square method, right? Good. So where we have the sum of the square of the residuals to be minimized or equal to 0, right? Good. So now that sigma v squared, so that v is a matrix. So the square of that v, sometimes it might not be a square matrix, other times it might be. So when it is not, we now have what? The matrix transpose multiplied by the matrix, right? Good. So we hope we have given you insight and then provided solution to this particular solving problem, whereby you have to multiply the transpose of a matrix by the matrix to get what? The square of that matrix when it is a what? A non-square matrix. However, if it is a square matrix, you just carry out what? Your direct multiplication, right? Good. Following the simple rule, or maybe the conventional rule, whereby the columns of the first matrix must be equal to the rows of the second matrix, which is already fulfilled when you are working with what? A square matrix. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a fantastic time. Bye.